Hello and welcome back to more FPGA-based FM music synthesizer demonstrations. So I didn't get very far with trying to create a new FM algorithm just because I got too excited about the thing that I was already creating. So if I go ahead and play a note, you can see the waveform of what I have and hopefully hear it too. Let me do a lower note. Pretty cool looking. So this is an algorithm where the first oscillator is feeding back on itself, so it's modulating itself. Let me go ahead and show you what that looks like. I'll have to turn off one other thing real quick. Turn you back to 0. There we go. So that's what the feedback on a single oscillator looks like. It starts to produce a sawtooth waveform or a ramp waveform. Which is very beautiful sounding. Sawtooths are often used for more bright sounds, such as like trumpets or brass type instruments. And so what I've done is I've taken this and added on the second oscillator. So the second oscillator is then coming in to modulate, but the second oscillator is at a higher frequency multiple. So instead of it being at 2, like it was in the last video, it is now higher than 2. I can't remember. One of the disadvantages of having this type of user interface is you tend to forget exactly what you had done, which isn't great, and which is why in the future this should have a user interface like this with nice little text boxes and LEDs to show off the value that it currently is at, even if the knob isn't turned the right way. This is good. Thumbs up, Korg. Boo me, because this sucks. But that wasn't part of what the research was meant to work on, so we're not too worried about it. All right, so let me just show you what happens when we add back in that second oscillator. Right, we see that again. If I go back to that frequency multiple, we can then see exactly what was up there. So I'm going to turn that all the way back to 2. So this is what it looks like with it at 2. Now this shouldn't look like it did before, because remember we have the first oscillator feeding back on itself. So this should look like what we had before plus that feedback on the first oscillator, which is why it has sort of a ramp-ish shape to it. It's all squiggly where the ramp should be, but it drops out at the end of that cycle like a ramp would. And so if we go ahead and turn up the frequency multiple again, we see that happening, which is very interesting. It's like a sine wave with a square wave in between. I find that very interesting. Let's go up one more. Okay. And it just keeps getting weirder and weirder sounding. So right now we're at 5. So the second oscillator is at 5 times the frequency of the first one. And that's where we were. So we found the answer. It was a frequency multiple of 5. And so this just produces a really strange sort of timbre. I can see that being a really cool bass synthesizer sound. Yeah, I don't know. I'm not good at playing, so we're not here for that though. So what I'd like to do now is to demonstrate what using the envelope gain on one of the oscillators will do to the sound. So what I'm going to do is I'm going to take the second oscillator and I'm going to make its gain envelope such that it starts out at full volume and then slowly dissipates. And what this should do is it'll take this weird kind of bright and like ear-piercing sound, and it will only be there for a little bit, and then what will be left is just the first oscillator feeding back on itself. And so what we're going to do is we're going to go to, we're going to first go to parameter 34. And remember, 34 was the envelope gain enable. So what we're going to do is go to 34. Got to look at this. It's in the 20 range, 30. I'm saying 34, but that's in hex, not decimal. Oh, so 34, bam. And then we're going to, okay, so this is an interesting, it's acting as a bit field. So when we look at the first 4 bits on the very right side, we will see the first one come on. This means that envelope gain is enabled for the first oscillator, and it will sort of count up in binary. But remember, we're treating it as a bit field. So whenever the second LED is lit, that means the envelope gain is enabled for that bit. And then, so that's 1 and 2. That's just 3. That's 3 and 1. Only 3 and 2. 3, 2, and 1. Okay, you get the gist. Now remember, we were going to enable it for the second oscillator. So I'm only going to turn it to where the second LED is lit. Okay, and then we're going to actually adjust the envelope gain. So here is the envelope gain settings for the second oscillator. Oscillator 1, 2, 3, 4, and we want number 2. And what we're going to do is we're going to set the sustain level to 0 so that as we hold the note, it should go to 0. And we'll set the attack to 0 so that it's already at full volume when we press it, and we'll set the decay to some small number so that it decays quickly. So let's go to, let's see, what are we trying to do? 28, 29, and 2A, or 20A if you want. I already forgot, 28. Okay, we're at 28. Press the button, turn it all the way down. Go to 29, press the button, turn it up to some small number. We'll do like there. And then turn it up to 28, press the button, and this is the sustain level, so we're turning it all the way down. All right, now hopefully if I did everything right, we should see exactly what I said would happen, which is where we start off with the same waveform as before, except the second oscillator is now going to dip out, which means the modulation it was doing is also going to dip out. And see, we're back to the ramp waveform. Okay, so that is the basis behind where FM can create different instrument noises. This isn't a great example because it kind of, I don't think I've ever heard an instrument make sounds like that. The idea is you want it to sound like an instrument and not like that. So maybe we'll try messing around here with some of the settings. For example, let's go back to the decay value, which was 29, and let's turn that down. So we'll do a smaller number than before. So it's a little faster. Well, that's great. Love to see that. Okay, so it is now faster. But I don't like the way that it sounds still. And I think what might help that is to change the frequency multiplier again. Remember, it was at 5, so let's bring it down. Let's go to setting number 8. And then instead of 5, we'll do 4. That's better. Okay. All right. So that is a demonstration of a more complicated FM algorithm than what you saw in the previous video. While I still have your attention, what I would like to do is demonstrate the unison effect, which I didn't show in the last video. that's the last major part of the system. Of course, the low-pass filter is also important, and so I'll actually demonstrate that as well. You know what? Why don't we go ahead and look at the low-pass filter. So, as I mentioned in the previous video, the low-pass filter's parameter number is 35, which isn't on my, restaurant napkin-esque diagram here. It's listed on the document, so you'll be able to see it. But I just am remembering it, which of course isn't helpful for other people. Okay, we're at parameter 35. Press the button, and the cutoff, I have to turn all the way up so we can get a baseline. And then I'm going to bring it maybe most of the way down. I don't know if you can hear, but it definitely is not as bright on the first part of the note. Let me go ahead and turn it down some more. So we're bringing the cutoff down, which means it will start attenuating higher frequencies. And it will start attenuating even lower and lower frequencies. More accurate. Yeah. It's also made it rather quiet. That's a lower frequency, so it might not be picked up on the low quality cell phone microphone. All right, so I'm going to turn the cutoff back up, all the way up, so we get the nice sort of distorted sound that we got before. Sorry, I'm really bad at narrating, but that's not important. All right, last thing to look at is the unison effect. So over here are the three settings for unison. We have the unison order, the unison pan, the phase, and the pitch. I'm going to leave the pan alone for now and just focus on the order, phase, and pitch. So let's go ahead and go to the unison order, which was, if you saw, number 20. The unison order is essentially just how intense you want the unison effect. And what it does when you increase the order is add more voices to the mix that are changed by the unison effects settings. So for example, if we have a higher order, we have a lot of voices, and those extra voices will say have a different phase or a different pitch than the original. And then it gets mixed in. And so that can sometimes sound bad, especially the pitch setting. So if I have a high unison order and I turn the unison pitch all the way up, all those extra voices that I've put into the mix have wildly different pitches than the original, which causes a very distorted sound and isn't necessarily good sounding, but in some cases you might want that horrible sound. Again, it's at the discretion of the musician. So I've seen it implemented in this way on several synthesizers. It's often called detuning. And so it is a thing. I'm not just throwing in a bad feature for the heck of it necessarily. All right, so I'm going to turn the unison order up to, 3. So what this effectively means, the setting is 3, but what that means is that we're going to have 4 voices. So we're going to have 2 voices that are pitch shifted up, and then 2 voices that are pitch shifted down. And the same with the phase. The first 2 will be phase shifted up, and the other 2 will be phase shifted down. And then they'll be phase and pitch shifted by different amounts. So one voice will be pitch shifted up a lot, and the other will be pitch shifted halfway up. And then same thing for the ones that are shifted down. And what would I do in the effect is send all of the upshifted values to the right channel and all of the left shifted or low shifted values to the left channel. So I'm going to go ahead and at least show you where we're at right now. It sounds the same, and both the left and right channels, which, by the way, sorry for not explaining earlier, but these are the two channels of the oscillator. And I do believe that the right channel is this one and the left channel is that one. And so as we can see right now, the left and right channels are the same. Once I start changing something like, say, the unison pitch value, if I turn that up, we can see it. They're different now. And there's some other strangeness going on. This is what's happening when those two voices are mixing in each channel. Remember, it's multiple voices at different frequencies. And so we're seeing each of those ramp waveforms sort of shift past each other, and they sort of they destructively and constructively interfere to form the waveforms that you see. And it has a really great effect. I love the sound of this effect. So let me just bring the mic closer. Wasn't that nice? So that's the unison effect. It is very useful for giving the sound a lot more body, especially with stereo headphones, because you're now actually making the sound that you're generating different in both left and right ears. And it makes it sound like it's surrounding you whenever you do that. And so it's very, very useful for creating cool sounds. Anyway, that's all I'm going to show for now. In the future, there may be more videos, but I just wanted to get these out real quick so that people have something to look at for now in terms of where the synthesizer is at. All right. Thank you so much for watching.